Alrighty, gonna go ahead and get started. So today's Sunday 312 review is just gonna be about using Logisim and how to translate what you worked on last week into working with these little digital circuits, or last 2 weeks. So first off, I just want to show y'all, um, this is a Logisim file, big file. These are the circuits. Within that file, whenever you make a new file, you're going to end up in main. Like that'll be the thing that auto pops up that is right up front. Okay, so this panel over here has everything you're going to need to create all the things for this class. So wiring, this is a splitter. So if you have a wire that is, say, 4 bits thick, this can take that 4-bit wire and split it into all 4 individually into 4 1-bit wires. The other stuff you could be using from here, this is a clock. It's basically just a timer. If you connect it to something and then let it play or go, it will turn on and off on, yeah, this one is 1 tick basis. You're probably not going to use a whole lot of this other stuff. Maybe a bit extender, but that's only if you're getting really fancy late in the class. Gates, you're going to be using these all the time, and I'm actually going to go through these for y'all just so we can understand a little bit better about how they're going to work. So first up, we have the NOT gate. So this would be your NOT, this little triangle with a circle on it. If I turn, so right now I have 0, so not 0 is 1. If I turn it on by clicking this hand and then clicking on the input, not 1 is 0. I can turn it back off. I got the inputs by going up here and just dragging them in. This is an output I got. You can also find a good amount of the regular stuff, like the regular gates that you're going to use a lot up here. But yeah, wire, you can definitely connect it and drag it like that. Personally, I prefer to say I delete this wire here. That's why it's a red and an E. E means error. If there's nothing connected to the input to give it an output, you can usually just click and drag. That way you don't have to drag in the wires separately. It knows what you want to do. Okay. So anyways, that's the NOT gate like we talked about. This is an AND gate. If you notice, I'm only using 1 instead of 2. That's because these are bitwise and yay. And that'll help us relate to the stuff y'all worked on last week's lab. So, as you can see, both zeros, 0, 1 0, 0, 1 0, or 0, 1 1. You get it. And then when I turn both of them on, then we get the 1 in the output. Okay. Next up, this is the OR gate. I'm honestly just going to use OR because otherwise it's just a line. So on this one, if neither are lit, then it's a 0, 1, or both get an A. Cool. So one thing I wanted to show y'all before we move on to some of the other gates is you can change the gates. So this is an AND gate. This started out like this. And what I did to make it have 4 inputs, 1 output, and bigger is I went over here to this area on the left side. I changed the gate side to wide, and I changed the number of inputs to 4. You can also change the font, so much other stuff. To be honest, not really helpful, not really useful. But the things I just showed you, super useful. So this one, the AND gate is only going to turn on if all 4 of them are lit. Yeah. Okay. Moving on. This is a NAND gate. So that basically means it's a NOT AND gate kind of together. So You just write it like that. So the NAND gate is going to be lit when it is not AND. So see both off, got a 1, either one, but both of them, and we turn it off. You can basically think of it as an AND gate that then goes through a NOT gate. So if I wanted to simulate it over here, I'm actually move this, copy these, which by the way, you can Control C, Control V, like make it super easy for yourself. Okay. So now instead of using this AND gate, I'm going to replicate the exact same thing by using an AND gate, which then goes into a NOT gate. So now if I connect these two, as you can see, they're always going to be lit the exact same. So pretty cool, right? Yeah, super cool. Y'all love that. Um, and then we're gonna move on. This is a NOR gate, so that means not or, depicted like that. And this one is gonna be on if it's not or. So right now it's neither of them. Or, or, or. And yeah. So this one would be the same as this, except for instead of that AND gate here, oh, sorry, it's a little off. Instead of that AND gate here, it's going to be an OR gate. And these two will have the exact same results. Now, here's where we get into some trickier ones. You've worked with these before in, like, if you took CSCE 120, 121, you've worked with them. It's a little caret symbol. These are exclusive ORs. So this one will only light if it is OR. So if I light both, it turns off. This one is a not exclusive OR. I think it's literally just, yeah, XNOR. Um, and oh, let's not look at that. So look at that. It would have the exact same results as an XOR gate feeding into a NOT. I'm gonna make these smaller really quick because this does take up more space. I don't know if you realize that. So these two are gonna have the exact same one. So when it's not exclusive or, so right now it's not exclusive or, it is exclusive or, so it's gonna be a no. Not exclusive or is exclusive or, so it's gonna be 0. And yeah. One other thing I wanted to show you is that there are other options for inputs and outputs. So this right here is an LED. You can change its on and off color. So for me, I'm gonna make it purple when it's on, just because I think that'll be fun. And when it's off, we want it to be red. So this is a NAND gate. So yeah, see how it's off? And that's just one of the many input outputs that you will see. So that was wiring and gates, plexus, blah, 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 blah. Input, output, and then input, output, extra. So that's an LED. Y'all will be working with the 7-digit display. There's also a hex digit display. Don't worry about that. Y'all be working with this one, which if you connect the lights to. So what I'm gonna do real quick is I'm just gonna set up for these. Okay. That's like it. Actually, that won't work. Don't listen to me. Don't do what I do. And then I'm also gonna put this one. And see, you can make corners really easily. Put that one there. That also is not gonna work. Ignore me. I know what I'm doing, guys. Oh, don't worry, don't worry. So once again, gonna put this one here, and then we're gonna branch off and put it over here as well. This one we're gonna put here. Make sure that if you're doing this, you're not putting the wires through each other. You can put the wire like this and it'll stay separate, but don't put different wires through an intersection of the same wire, if that makes sense. See how I'm going, like giving it space. And then this one. So now these are all connected. If I turn this one on, see the two things it lights up? It lights up this dot in the corner and it lights up that segment. This one, that segment, and that segment. I turn them all on, they're all lit. Now if I go in and I disconnect all of these, the bottom half is no longer lit. It's because there's no input, so the input is 0. So yeah, that's just one of the many input-output displays you can work with. Okay. The next area we're going to talk about is this TTL? No? Yeah, TTL. So this is where you can find the more chippy looking ones that have multiple input output. So this one right here is the 7408, which is the quad 2 input AND gate. That means that there are 4 AND gates on this chip or circuit. Let's not get the terminology confused. My bad. So right now I have these 2 inputs into these, and it's the output. So that is one of the 4 sections. So this is a gate, this is a gate, this is a gate, this is a gate, and this is a gate. And these 2 don't have input or outputs on them. So as you can see, turn these 2 on, the same result as the ANDs. The 2 on, out, 2 on, out. Okay, cool. So that is all of the like super basic stuff. Now, remember when I showed you earlier that I have 2 chips within this file? This is my other chip. This is the encoder. That is not currently an encoder because I didn't make it because that's part of Dale's assignment. Yay! But so all I did to get this is I'm gonna show y'all what the encoder looks like real quick, and then I'm gonna show y'all what I did to get a new chip from a different file into the main file. So if I double click, this is the encoder file. I fear I maybe, yeah, literally all it has is an input to an output. So whatever the input is, the output will also be. So going back to here, whatever the input is, the output will also be, because it's literally just a line. It has the same name as this, and you can also tell it which way you want it to face. So I just flipped it. Don't do that unless you're ready to make your own styles, which y'all are not yet, because we just started learning. So don't get too excited. Hold on. So what you want to do is you will go to Project, Add Circuit, give it a name. So for this one, I'm going to give it the name Test because we're testing things. I'm going to go ahead and give it an input, which I'm going to name Test In. All I did to name it was I double clicked on it, gave it a name. It will not let you name anything the same as something that already exists. So if I want 2 inputs and I try to name it Test In, it will not let me. So what you should do is you should name things Test In 1 and Test In 2. Or give them more descriptive names altogether. Okay, so my goal for this one is we're gonna do an exclusive OR gate. And then I'm gonna put my output here, and we're gonna name this test out. Cool. Now, you can totally play around with it on here, right? We already played with it earlier, so it's not really necessary to do that right now. But you can also go back to main or literally any other file. And I'm gonna click on test. I'm gonna single click it, not double click it, and then drag it in. I literally just clicked on it and then moved to my workspace, plopped it right down. And now you can see even my inputs are labeled as test one, test two. So I'll go ahead and connect those. I'll give it an output, connect those, and whatever stuff is going on inside that chip, this will show through the inputs and outputs that I'm now giving it to test with. So you can see exclusive OR. That means you can do so many complicated things inside this test chip. Literally so many, you can have a million gates. And if you have two inputs and one outputs, no matter how many things you have in between it, that chip on your main is going to have two inputs and one output. So you're basically condensing all of whatever is in these files down to something that is easier to work and place together with other pieces. So, for example, I don't want this test output to be a single bit. I want it to go to my clock. So what I'm going to do is I'm going to connect every single one of these to the 7-bit or 7-segment display. I can also change the color for these. Super fun and cool. So now if I play around with it, I'm gonna light every single one of those up whenever the condition is true. Okay. So what this means is you can create encoders and decoders in separate chips and then just drag them in. If it's an encoder, remember you're going from n to, or you go from going from 2 to the n inputs to n outputs. If it is a decoder, that's going to be 2 to the n input, or n inputs to 2 to the n outputs. You're basically turning things from decimal to binary, binary to decimal. Okay, so that is everything, all the Logisim stuff I had planned for today. So we went over all of the basic gate types, changing gates to work with what you need for your inputs, your values, how many data bits you're working with, etc. Talked about these TTL chips, which are part of your lab that you'll have to look up and learn more about. Talked about 7-segment displays and other displays and how to use them. Talked about what a NAND gate is, so an and a not, what a NOR gate is, an or and a not, what an XNOR gate is, an exclusive or and a not. And then we talked about a little bit about what encoders and decoders are and how to use chips in Logisim. Okay. So I will take any questions. Remember, you can always just DM me, send me an email. I don't mind at all. Thank y'all.